Okay, this is problem number 1 on section 9.2. First of all, okay, read the problem and see what this problem is about. Okay, pause the video and read. Okay, after you identify the claim in this situation, well, you gotta test the claim that the content of cans of Diet Coke have weights with a mean less than the mean of the regular soda. So this is all the information for a 31 cans of Diet Coke and 31 cans of regular soda. So this is a test for independent means. I mean, these two sets, they are not related at all. That's why it's called independent. So since the claim is that the mean mu one, I mean, let's call this mu one, the one from the Diet Coke, is less than mu two, the regular is mu two. So this is the claim, okay, according to this paragraph. Since the claim contains inequality, it's gotta be on the alternative hypothesis. Remember, the null hypothesis only contains equality. So the claim is here, okay? So next step is finding the test statistic in the p-value. So to obtain this, screen on the calculator, you go to stat, and follow the step stat, test, to the right side with the arrow. And number 4 says two sample t-test, number 4. And you gotta enter all this data. Mean 1 is this, mean 2, that's the sample mean. The sample mean, remember this means sample mean and this population mean. So the sample mean, sample size is 31, so that's why you have to type 31 here. And the standard deviation of the first sample, which is 0.0433, is right there, right here. Now for mu2, you got n equals 31 as well. The mean of the sample is 0.81047, which is right there. And the standard deviation is 0.00743, which is right here. Okay. So you need to select the null hypothesis, highlight the null hypothesis, which is less than, okay? We have this inequality symbol. For pool, we always select no. And this is, okay, you only select the one when you know that the standard deviation of this population is the same as the standard deviation of the second population. That's when you say full yes. But for this chapter, we don't have any situation like that. Okay, so we assume here that the population standard deviation of the first population, I mean, of course, is different than the second one. Okay, this is not the same as this. This is sample one. This is population. So we always do it like no, and then we can calculate. Okay, or we can select draw. You select draw, you get this shape. You can calculate. You get the test statistic right here, which is this number, and you get the p-value, which is 0. Again, if you do the same, I mean, stat, test, number 4, but you select a draw here at the end, what you get is this picture right here. Okay. Okay, let me click again. Stat, select number 4, and you select this. Hold on. Draw here. You press enter. You get this shape. Okay. So we got that the p-value is 0. Okay. Okay, the p-value is 0. So and the significance level is 0.01. So the p-value in this case is less than the significance level. Okay, so less than alpha. When the p-value, which is 0, is less than alpha, we reject the null hypothesis, okay? And the claims on the alternative hypothesis. So this is the way you word it out. Refer to the tables I gave you previously on other videos. There are several ways to formulate the conclusion, but that depends on these two elements. Either you reject or fail to reject, and what the claim is. In this particular situation, we reject the null hypothesis, and the claim is on the alternative hypothesis. That's why this is the way you word the conclusion. So for the second part, we have to construct the confidence interval. Okay? For that, you gotta go to stat, test, go to stat, test, and select number 4. Okay, that's number, no, it's not number 4, sorry, it's number 0. It's actually down here. Number 0, two sample t interval. So you press 0, and you don't have to type that again. All the data is right there. The only thing you gotta do different is that the confidence level, since we have a significance level of 0.01, and this is a one-tail test, since you have mu1 is less than mu2, you have actually a left tail, right? It's one tail. Okay? When you have a mu1 is not equal to mu2, we have a two-tail test. Okay? But in this particular situation, we don't have this situation. We have this one. This situation is a left tail. That's why we select the one tail test. So we select the 98%. So that's the only thing you gotta modify the 0.98. Okay. And on poll we keep no, and we press on calculate, and that's how we obtain that screen right here. Okay. We obtain this screen. Again, you gotta be careful on this part, because if it is two-tail test, you gotta use 99%. If it is one tail, you gotta use 98%. Well, these are the values right here of the limits of the confidence interval. And since the confidence interval contains only negative values, that means support the idea in the conclusion that mu1 is less than mu2, because the interval contains only negative values. Okay? And that's how you do this problem. Okay? Let me just mention about this again. If the interval contains 0, I mean that you have a negative and a positive number, that supports the idea that mu1 is equals to mu2. If the interval contains negative values, that supports the idea of mu1 is less than mu2. If the interval contains positive values, here, I mean these numbers right here, that supports the idea of mu1 is greater than mu2. Okay? These are all the possibilities you have. Either the interval contains 0, I mean you have a negative number and positive number, the interval contains only negative values, or the interval contains only positive values.